Hi guys, so today we will gonna learn how to solve a natural language processing problem using this dataset. We have three different columns, which the first one is the ID, which is useless and we will be removing it. The label, which is the class and is a binary classification, so the class is 0 or 1. And then we have the tweet. The tool that I'm using is called Anaconda Navigator, and the IDE is Spider. Now you need to create a virtual environment, which I call the Lavoro, and you need to install all the libraries. To install the libraries, you should go to this button on the virtual environment, open terminal, and then write pip install and the name of the libraries. But we will see how to do this soon. So the first thing we should do is to create a new folder, and then inside this we should copy and we should paste the dataset, which I will be linking in the description of this video, and then a new file called, for example, hate tweet.py. Select yes, and then open this file inside Spider. So the library that we will be using on this example are NumPy, so write import NumPy as np, and if you don't have NumPy, just write pip install NumPy on here. So just open the terminal and write pip install NumPy and press enter. Now, if you don't have virtual environment, just click create, select a name, select Python, and the version of Python should be like 3.7, and just click OK, and then just install the Spider, which is the IDE. Now back to our project. Once you have installed and import NumPy, we also need pandas, so import pandas as pd, and if you don't have pandas, just write pip install pandas. Then we need random TensorFlow, and if you don't have TensorFlow, write pip install TensorFlow. Or if you want to select a specific version of TensorFlow, just write pip install TensorFlow 2.2. Sorry, 2.2, which is the one that is able to work with Keras. And then write import OS, and from Keras import back and as K. For now, don't look this part of the code, because we must select this path to see the graph that we will do. So for now, just leave it here. The first thing you have to do is to set all the random seed to get the same result every time you run the code. Since we're using Keras and TensorFlow, the syntax to do this is as follows. Here you can select which number you want to set the seed. In this case we have 1, 2, 3, 4. For now we can comment this part of code, and we can open the dataset by the method readCSV by pandas, and the encoding format is UTF-8. Now we print the dataset and we take only the useful columns, which, as we already have seen before, are the tweet and the label. We just run the code, and as we can see, we have only the needed column here, 2 columns. The next step is to study the dataset. As the first thing, we print the total number of rows, which would be the record present in the dataset, and next we print the number of available classes inside our problem by using the method unique of the pandas library. We call this method inside the data frame of the column label. Then we print the number of record for each class, and running the code we get all the results needed for the study. So we get the total number of rows and the different label of this problem. The next step is to clean our data. We then go to import the NLTK library and the stop word, including the library array and string. Next, we're going to define a function that takes a text as input and applies some changes. For example, all URL in the tweets, all punctuation and all stop word will be deleted. Let's apply this function to the list of our tweet by creating another column inside the data frame called text clean. We then print the row 100 and we can check the difference between the original text and the cleaned text. For example, now if I run this code, it will take a while, but it's done. For example, all the hashtag will be deleted. Well, the first letter of every hashtag will be deleted, and then, as you can see, every link that are not very useful for the classification will be removed. So from now we will do feature selection, which means that we take very different kind of feature that are useful to the model to predict give more performance to predict some label. So we will count the number of word inside a tweet, the number of letters inside a tweet, the mean length of each word inside a row. We then count the number of stop word inside the tweet, and then we count the number of punctuation inside the tweet. And then for each different kind of method, we create a different column inside our data frame. So let's call feature 1, feature 2 to feature 5. Let's work with the text. First of all, we shuffle the data frame, and then we drop the tweet column, because from now on we will working only with the cleaned text. Now we cast this text to a list, and then we cast every different tweet to a string, and then we initialize the tokenizer of Keras. We will give in input the list of text that we have created before, and then we count the number of words inside the vocabulary. Now we save the max len of our tweet, because we will use this specific number to specify the input of our neural network. So next we will print the text before the post padding method, and then we will print the text after the post padding method. This is useful because every rows inside our the dataset must be at the same length to be a valid input for our model. So if we execute this program, we can see that the length before the post padding was 24, and the length after the post padding is 41. So now from now on, every different tweet will be of length 41. So now we will filter all the columns that are useful for training the model, which are the token padding of each tweet, and then the feature that we have calculated before. And last, we have the label to be predicted by our model. We then select the values of our data frame, which are 0 to 6 and 6, and then we split the data, and we will give 80% to the training set and 20% to the test set. Now remember that we have in the first cell of our data frame, well, of our array that is called X, the text after the zero padding was applied, and then of every other feature we have all the features that we have previously calculated here, like the number of words, the number of letters, etc. Now we need to split those information, because on one side, on one input, we will have the text, and on the other input we will have all the different features that we have calculated. So in this variable that is called xtrain embedding, we will select only the the text token padding, and we apply the type float32. Then we select all the different feature, and we cast those feature as before, and we will do the same exact thing for the test set. Of course, the name of the variable must be different. For the label, we must select the categorical type of data. So 1 became the array 01 and 0 became the array 10. And this format is required by Keras. So we just apply the toCategorical method by selecting 2 because there are 2 classes. For the model creation, we just import all the different layers that we need to construct this model, and then we define the embedding dimension, which is 41 for this problem, because we saved this variable inside, we saved this value inside the variable called maxlen. We then specify 2 different input, which the first one is the text, and the shape is equal to 41, is equal to maxlen. And then we define the embedding layer of Keras, and then we insert the size of the vocabulary, the embedding dimension, which is always 41, and then the input length, which is also 41, and then we set the trainable true. So the weight inside this kind of layer will be training. Then we specify this goes after the input, the text input, and then we specify a flattened layer. For the second input, we have all the feature, which are the 5 feature. So we then select the shape 5, which is the column length of the xtrain feature variable, and then we just define our model. So we concatenate the x, which is the text input, and then the input of the feature, and then we define our model. I choose to give 3 different kind of layer, which on the first layer we have 300 neurons, on the second layer we have 150, and on the output layer we have two neurons, because we are considering a binary classification problem. So we define the model, and we give the 2 different input and the model that we have defined. Now we compile our model with the compile method, and at last we plot our model, and we can give this kind of photo. So we have 2 different input layer, the embedding, the flattened layer, the concatenate of these 2 different input, and then we have the 3 different hidden layer and 1 output layer with 2 neuron. Once we have visualized the model through the plot method, we then go to write this function, just copy this function, and this function will show the performance of the model during the training. So after that, we fit the model, and we save all the different kind of information that the fit is giving inside the history variable. Now, to fit the model, we should select the train embedding on the first input, the train feature on the other input, and epsilon, which are the label, as normal. Now I chose this 64 batch size and 3 epochs, but you can choose whatever value you want. Let's go now for the testing. We call the predict method of our model of the input of the test input, where on the other side, on one side we have the embedding, and on the other side we have the feature. So we will then call the classification report to see all the performance of our model, and then we will print the confusion matrix of the performance. And then we also plot the history of our model, so we can see the performance during the training. So now I will execute my code, and we will wait for the 3 epochs. Now, as you can see, the accuracy is 87%, which is very, very good. And also the precision recall F-score method are also very high. So this value are all presented inside the confusion metric, so we can see that our model is doing really, really good. Also, we printed the performance during the training. We have the validation and training accuracy, and as you can see, in this case, 3 epochs maybe are not enough to fit the model correctly. So you should try a different value for the epochs for the batch size and see which value are the best for your model.